This is a continuation of the Chapter 10 review with problem 34. In problem 34, we have the segments of chords theorem, and that says that the product of the segments of one chord equals the product of the segments of a second chord. So QP times PS equals TP times PR. So let's go ahead and start writing that down and see if we can figure out what these variables are. So we know that for 34, QP, which is 6 minus X, times QS, 2X, equals TP, which is X plus 3, equals PR, which is X. Multiplying this through, 2x times 6 is 12x. Negative x times negative 2x, or times 2x, is negative 2x squared. And that equals x times x is x squared. X times 3 is 3x. Now combining our terms, I can add 2x to both sides. So I get 12x equals 3x squared plus 3x. And if I subtract 12x from both sides, 0 equals 3x squared minus 9x. This quadratic is a bit easier to solve than the last one we had to deal with. We don't have to do a lot of that factoring stuff, but we still have to factor. So let's set this equal to 0. And what we have here is a couple of common terms inside these. We have a 3 in each one of the terms. There's a factor of 3 here, and there's also a factor of x. So if I divide this by 3x, I'm just going to pull out a 3x, and I divide this term by 3x, 3x squared divided by 3x, the 3's cancel out, one of these x's cancel out, and you have x left. So 3x squared divided by 3x is x, and 9x divided by 3x is simply 3. So again, applying the zero product rule, if this times this equals 0, one of these two has to be 0. Assuming it's this one, if 3x equals 0, then x equals 0. That obviously can't be the answer because you can't have a side length here of 0 length. So we can eliminate this one. Let's assume now it's this one. If x minus 3 equals 0, then x has to equal 3. And that works out fine. If we put a 3 in here, we get valid numbers for each one of these segment lengths. So our answer for 34 is x equals 3. Let's move on to problem 35. In problem 35, this is the segments of secants and tangents theorem. And what it says is the product of the entire secant segment and its external segment equals the square of the tangent segment. Let's go ahead and write that down, see where it leads us. For 35, we have the entire secant segment, which is x plus 8, times its external segment, which is 8, equals the square of the tangent segment, 12 squared. Multiplying through, we have 8x plus 8 times 8 is 64 equals 12 squared, 144. We subtract 64 from both sides, so we get 8x equals 80, x equals 10. Now we'll move on to problem 36. In problem 36, we have a word problem. I know, you hate word problems, but remember, life is a big word problem. So let's embrace the horror here and see where it leads us. So it says, a local park has a circular ice skating rink. You are standing at a point A, about 12 feet from the edge of the rink. So we're sitting out here and we're 12 feet from the edge of the rink here. The distance from you to a point of tangency on the rink is about 20 feet. So the distance from you here to a point of tangency B is 20 feet. We're looking for an estimate of the radius of the rink. So we're looking for this distance here. Well, this is the segments of secants and tangents theorem, just like we finished. And so let's set that up and see where it leads us. We know that the length of the entire secant segment, so that's r plus 12, r plus 12, times its external segment, so this whole thing times 12, equals the square of the tangent segment, 20 squared. All right, let's see what this equals. We can simplify this. R plus r is 2r plus 12 times 12 equals 20 squared is 400. Now we can multiply through. This gives us 12 times 2r is 24r plus 12 times 12, 144. And that equals 400. Now we subtract 144. 24r equals 256. We divide by 24. R equals about 10.7. It's 10.66 repeating. So this is approximately equal to 10.7. So that didn't turn out so horribly bad after all. Let's go ahead and move on to problem 37. In problem 37, we're looking for the standard equation of a circle. We need the radius and we need the center point. The radius we can see is 1, 2, 3. So in 37, the radius is 3, and our center point is at 4, negative 1. And so our equation is x minus h squared plus y minus k squared equals r squared. To substitute in here, our h is 4, so x minus 4 squared plus y minus our k is negative 1. So minus negative 1 squared equals, and our r is 3 squared. That gives us x minus 4 squared plus y. This is a plus 1 squared equals 3 squared is 9. And that's the standard form of the equation of a circle with center at 4, negative 1 and a radius of 3. Let's go on to 38. For 38, the circle is at, the center point here is at 8, and it looks like 6. 8, 6, and our radius is, this is 2, 4, 6. So it's 6. It's the y value here. 6. Again, using this form, we have x minus h, which is 8, squared, plus y minus k, which is 6, squared equals the radius squared, 6 squared. That gives us, as a final form, x minus 8 squared plus y minus 6 squared equals 36. And for 39, our center is at 0, 0. And it looks like our radius is 2, 4. So we have a radius of 4. We have a radius of 4. And the center is 0, 0. Substituting in, we have x minus 0 squared plus y minus 0 squared equals 4 squared. This works out to x minus 0 is just x, so that's x squared. Y minus 0 is just y, so that's y squared, equals 4 squared is 16. Let's move on to problem 40. In these problems, we're just given a center and radius and asked to find the standard equation of the circle. So this is about the same as what we were just doing without the picture. So in 40, again we have x minus h squared plus y minus k squared equals r squared. So it's x minus 0 squared plus y minus 0 squared equals 9 squared. This works out to x squared plus y squared equals 81. For 41, we have x minus, the h is negative 5, so this is negative 5 squared plus y minus 2 squared equals 1.3 squared. This gives us x plus 5 squared plus y minus 2 squared equals 1.69. And number 42 is x minus 6 squared plus y minus 21 squared equals 4 squared. So this is x minus 6 squared plus y minus 21 squared equals 16. And for 43, we have x minus negative 3 squared plus y minus 2 squared equals 16 squared. This gives us x plus 3 squared plus y minus 2 squared equals 256. I'll go ahead and erase the board for problem 44. And for 44, we have x minus 10 squared plus y minus 7 squared equals 3.5 squared. X minus 10 squared plus y minus 7 squared equals 12.25. For 45, we have x squared plus y squared equals 5.2 squared. That gives us x squared plus y squared equals 27.04. And this was because of the 0, 0. We'll work problem 46 in the next session.